Most people first encounter Linux through general-purpose distributions like Ubuntu, Fedora, Debian, or Mint. These systems are designed to be flexible, adaptable, and capable of serving a wide range of users, from students and developers to businesses and hobbyists. They are the Swiss Army knives of the Linux world. But beyond these mainstream distributions exists another fascinating category: Linux distros built for one thing. Not for everything, not for broad appeal, just one primary purpose. And surprisingly, that narrow focus is exactly why they succeed. A single-purpose Linux distribution is built around a clearly defined goal. Instead of trying to accommodate every workflow imaginable, it optimizes for one task, one environment, or one type of user. It might be security testing, media production, digital forensics, privacy, retro gaming, firewall routing, or even running entirely in RAM for extreme portability. By narrowing the scope, developers remove unnecessary components, fine-tune performance, streamline user experience, and create tools that feel almost purpose-built at the hardware level. These systems are less about general computing and more about mastery of a niche. Take Kali Linux as one of the most recognized examples. Kali is built specifically for penetration testing and security auditing. While it's technically possible to install penetration testing tools on Ubuntu or Arch, Kali integrates hundreds of pre-configured tools directly into the system. It is not just about bundling software. It's about designing the environment around the workflow of ethical hackers. Network sniffers, exploit frameworks, password crackers, reverse engineering utilities, everything is categorized and accessible. The kernel may include patches that support wireless injection. Default settings are adjusted to avoid compromising operational security. Even the live boot feature allows testers to use it without installing anything on the host machine. Kali works because it eliminates setup friction. Security professionals can focus on testing rather than configuring. Then there is Tails, a distribution built almost entirely around privacy and anonymity. Tails routes all internet traffic through the Tor network by default. It is designed to leave no trace on the host machine, running from a USB stick and forgetting everything once powered off unless persistent storage is explicitly enabled. This is not just a Linux distro with Tor installed. It is an operating system engineered around the assumption that the user may be under surveillance. Applications are pre-configured to avoid leaking IP addresses. Unsafe network connections are blocked. Cryptographic tools are built in and easy to access. The desktop environment is simplified to reduce attack surface and confusion. By committing fully to privacy, Tails creates a coherent experience that a general-purpose distro could not easily replicate without significant manual effort. Another compelling example is OpenWrt, a Linux distribution built for routers and embedded networking devices. Instead of being a desktop OS, it transforms consumer routers into highly customizable networking systems. OpenWrt is lean, modular, and optimized for limited hardware resources. It provides advanced routing, firewall configuration, VPN integration, traffic shaping, and monitoring capabilities. What makes OpenWrt powerful is not flashy visuals or broad compatibility with desktop software. It is precision. It strips away unnecessary features and focuses entirely on network control. In doing so, it empowers users to turn inexpensive hardware into enterprise-grade networking equipment. A general-purpose OS would be bloated and inefficient in that context. OpenWrt works because it understands the constraints and needs of its environment. Consider LibreELEC, a distro built specifically to run Kodi as a home theater system. Its slogan could practically be, "Just enough OS for Kodi," and that's exactly what it is. LibreELEC strips Linux down to the essentials required to boot and run a media center interface. No unnecessary desktop applications. No office suites, no development tools. The result is a fast, stable, appliance-like experience. You install it on a small device like a Raspberry Pi, plug it into a TV, and it behaves like a dedicated media box. Because the system is purpose-built, updates are streamlined, performance is optimized for media playback, and the user interface is consistent. The simplicity enhances reliability. By doing one thing, being a media center, it does it exceptionally well. The same philosophy appears in distributions like Proxmox VE, which focuses on virtualization management. While based on Debian, Proxmox is engineered to serve as a hypervisor and container management platform. It integrates KVM virtualization and LXC containers with a web-based management interface. Instead of manually installing and configuring virtualization tools on a base distro, administrators get an environment tailored for hosting virtual machines. Storage management, clustering, backups, and networking are integrated into a unified interface. The operating system becomes an infrastructure appliance rather than a personal computer. This specialization reduces complexity for system administrators and improves deployment efficiency. There are also distributions like SteamOS, designed primarily for gaming. SteamOS integrates the Steam platform deeply into the operating system, optimizing performance and compatibility for gaming hardware. With the rise of the Steam Deck, this approach has proven particularly powerful. SteamOS is not just Linux with Steam installed. It includes optimizations like Proton for running Windows games, controller-friendly interfaces, and system-level tuning for gaming workloads. By focusing on gaming as the primary function, it simplifies the experience for users who may not even realize they are using Linux. The narrow focus removes barriers and increases accessibility. For musicians and audio engineers, Ubuntu Studio provides another example of focused design. It comes preloaded with low-latency kernels and professional audio, video, and graphic production software. Audio production requires careful configuration to minimize latency and ensure hardware compatibility. Doing this manually on a general-purpose distro can be time-consuming and technically challenging. Ubuntu Studio handles these optimizations out of the box. The distribution aligns system architecture with creative workflows, making Linux more accessible to artists who might otherwise be intimidated by complex setup processes. Digital forensics professionals rely on distributions like Kane or SIFT, built specifically for forensic investigation. These systems include tools for data recovery, disk imaging, memory analysis, and evidence preservation. They are designed to maintain data integrity and follow forensic best practices. Often, they can run in live mode to avoid altering evidence on a suspect drive. The specialized environment ensures that investigators have immediate access to the tools they need without risking contamination of evidence. The operating system becomes part of a methodological process rather than just a computing platform. Even in extremely minimal contexts, specialization thrives. TinyCore Linux, for example, is built around being as small and lightweight as possible. It can run entirely in RAM and boot on very old hardware. Its purpose is not to provide a full desktop experience out of the box, but to serve as a minimal base that users can expand selectively. By prioritizing size and modularity, TinyCore demonstrates how focusing on efficiency creates unique value. In environments where hardware resources are scarce, a general-purpose distro may be too heavy. TinyCore succeeds by embracing constraints. What all these distributions share is intentional limitation. In mainstream software culture, limitation is often perceived as a weakness. More features are assumed to be better. Broader compatibility is seen as progress. But in specialized Linux distributions, limitation becomes strength. By defining clear boundaries, developers can optimize deeply within those boundaries. Performance improves because unnecessary services are removed. Security strengthens because the attack surface is reduced. User experience becomes coherent because every design choice aligns with a central goal. There is also a psychological dimension to this success. When users choose a single-purpose distro, they adopt a tool with a clear identity. This clarity reduces decision fatigue. Instead of configuring dozens of options, users step into an environment already shaped for their task. The system communicates its purpose immediately. A penetration tester launching Kali knows they are in a workspace built for ethical hacking. A privacy advocate booting Tails understands the environment prioritizes anonymity. This alignment between intention and design fosters trust and confidence. Another reason single-purpose distros work is community focus. General-purpose distributions must balance the needs of diverse user bases, which can slow decision-making and create conflicting priorities. In contrast, niche distributions attract communities united by a shared goal. Developers and users often overlap. Feedback loops are tighter. Improvements target specific workflows rather than abstract general use. This creates rapid refinement and strong domain expertise within the project. There is also a practical engineering advantage. Software complexity grows exponentially with feature expansion. By narrowing scope, developers reduce maintenance burden. Fewer packages mean fewer compatibility issues. A smaller codebase is easier to audit and secure. Updates can be tested more thoroughly within a defined use case. Reliability increases because there are fewer variables. In mission-critical environments like routers, forensic labs, or servers, reliability is far more valuable than versatility. Interestingly, many single-purpose distros function more like appliances than traditional operating systems. Users do not think about the underlying Linux kernel or package manager. They interact with a web interface, a media center UI, or a security toolkit. The operating system fades into the background. This appliance model is powerful because it bridges the gap between open-source flexibility and consumer-friendly simplicity. It transforms Linux from a tinkerer's playground into a specialized instrument. However, specialization does not mean inflexibility. Many of these distributions remain open and customizable. The difference is that customization begins from an optimized baseline. Instead of starting with a blank slate, users start with a tailored foundation. This approach accelerates productivity while preserving freedom. The success of single-purpose distros also reflects a broader principle in technology. Constraints drive innovation. When developers commit to solving one problem exceptionally well, they explore deeper optimizations and creative solutions. LibreELEC's minimal footprint, Tails traffic isolation mechanisms, OpenWrt's modular package system, these innovations emerge from focused intent. A general-purpose distro might never prioritize such extreme optimization because it must remain adaptable to countless scenarios. There is a lesson here about identity and software design. A product that tries to serve everyone often becomes diluted. A product that clearly defines its audience can deliver transformative value to that audience. Linux, with its modular architecture and open-source philosophy, is uniquely suited to this experimentation. Anyone can fork a base distribution, strip it down, add specific tools, adjust the kernel, and create something new. This freedom encourages specialization. Some critics argue that fragmentation is a weakness of the Linux ecosystem. There are hundreds of distributions, many with overlapping features. But from another perspective, this diversity is a strength. It allows Linux to penetrate domains that proprietary operating systems might ignore. From routers and IoT devices to supercomputers and gaming handhelds, specialized Linux distributions adapt to contexts far beyond the traditional desktop. Even corporate environments benefit from this model. Red Hat Enterprise Linux, while more general-purpose than niche distros, is optimized specifically for enterprise stability and support. Its long-term support cycles, certification processes, and predictable updates cater to business needs. In this sense, it too is specialized not for hacking or media playback, but for enterprise reliability. Ultimately, Linux distros built for one thing succeed because they align design with intention. They remove excess. They optimize deeply. They serve clearly defined communities. They transform computing from a general abstraction into a purposeful tool. In a world increasingly overwhelmed by feature bloat and complexity, there is something refreshing about software that knows exactly what it is meant to do. When a system is built for one thing, every component contributes to that mission. Boot times shrink because only essential services run. Interfaces simplify because irrelevant options disappear. Documentation becomes clearer because the scope is defined. Security improves because fewer pathways exist for exploitation. Performance becomes predictable because workloads are anticipated. The beauty of Linux is that it accommodates both extremes, the expansive general-purpose distro and the laser-focused specialist. But the enduring appeal of single-purpose distributions reveals an important truth. Sometimes the best way to build powerful software is not to add more, but to choose less. Not to chase universality, but to embrace specificity. In the end, Linux distros built for one thing demonstrate that focus is not limitation, it is strength. By committing fully to a single objective, they achieve levels of efficiency, clarity, and reliability that broad systems struggle to match. And in doing so, they remind us that in technology, as in life, purpose often matters more than possibility.